Hello everyone! Today we're going to be applying the vocabulary we went over the previous days. Okay, so here in front of you I have a diagram, two parallel lines, the blue and the orange, and a purple transversal crossing it. The first question I have for you is what is the relationship between 2 and 6? Now if we take a look at both intersections, so this intersection and that intersection, both angle 2 and angle 6 are in the bottom right-hand corners of those boxes. So that makes them corresponding angles. Okay, sweet. Number 2 asks us, well, if angle 3 measured 45 degrees, what is the sum of 6 and 7? All right. Well, 3 measuring 45 degrees tells us a couple of other things about this problem. Right. It tells us that angle 2 is also 45 degrees because they're vertical angles. We already answered in number 1 that 2 and 6 are corresponding, which means they have the same value. And 7 is the same value as 6 because they're vertical angles. Well, what that tells us now is that if 3 was 45 degrees, that means angle 6 is 45 degrees, so is angle 7, and together, 90. Perfect. Erase these little green things, hopefully not the actual lines or numbers. I hoped wrong. Come on, you can do this. You can do this, Miss Gooman. I did it. Okay. Number 3. Let's look at the relationship between angles 6 and 4. They are on different intersections, but they do happen to both be inside of my parallel lines. They're in between them. Not only are they inside of my parallel lines, they're on the same side of my transversal. So that means that I can call these same side interior angles. They're on the same side and they're inside. All right, number 4. If angle 8 measures 115 degrees, what's the sum of angle 5 and angle 1? Again, let's see what angle 8 actually tells us. If angle 8 is 115, so is 5 because they're vertical angles. We have 8 corresponding with 4, so that's 115 degrees. And then we have angle 1, also 115 degrees. Well, great. Angle 5 I highlighted because it was also 115 degrees. So let's add 115 and 115, and we get 230 degrees. Whoops. All right. Sweet. I'm going to try that eraser again. I can do this without deleting lines. What do you think this time? Okay, 5 went, 8 went. Oh my god, you can do it. 4? Ah, no. No success there. Okay, let's try 1. 1 worked. How about 4? Come on, 4. Yes. All right. Number 5. What's the relationship between angle 6 and angle 7? Well, angle 6 is right here, and right across from it is angle 7. They are formed from 2 intersecting lines. They're across from each other. They are vertical angles. All right. Number 6 says if measure of angle 1 is 133 degrees, let's find the angle measures of 5 and 6 and add them together. All right. So again, let's see what else is 133 degrees. 1 is 133, so is 4 because they're vertical. 4 corresponds with 8, and 8 is vertical with 5. Okay, well then I for sure know that 5 is 133 degrees. Well, 5 and 6, if you take a look, they form the blue line. They're a linear pair. And what do we know about linear pairs? Well, they add up to 180 degrees. So I don't really need to find the angle of measure 6 because I know that when I add 5 and 6, they will create a straight line which makes 180 degrees. All right, that was easy. Let's erase these little green things again. Yes, 5 worked, 8 worked. Oh gosh, this is the 4 that didn't work last time. Come on, 4. Yes, yes. All right, number 7. What is the relationship between angles 6 and 3? Well, 6 and 3, they're across each other on this transversal, so they're alternate because they're on different sides. And they both happen to be inside of our parallel lines. Alternate, interior. All right, let's do this last one, number 8. If angle 3 measures 60 degrees, what's the sum of angles 4 and 8? All right, let's see what else is 63 degrees. If 3 is 63, then so is 2. If 2 is 63 degrees, then so is angle 6, and so is angle 7. All right, well, we're looking for 4 and 8. Womp womp. Nothing that we highlighted. Okay, well, angles 3 and 4, if we look at them, they form a linear pair on this orange line. So we can do 180 minus 63 to find the angle, the measure of angle 4, as well as angle 8, since they are corresponding angles. Okay, so 180 minus 63 is 117 degrees. And we're going to add it twice for angle 4 and 8, 234. Okay, sweet. That was what we did for these types of problems. We practiced our vocabulary, and we used the properties to solve the problem. Lastly, we solved problems like this one. And what we want to do here is find all of the angle measurements for this intersection. So this one, this one, this one, and that one. Okay. This is an intersection of 2 lines, so that means it created 2 sets of vertical pairs. There's a vertical angle with this vertical angle. They're across from each other due to an intersection, which means I can set x plus 4 equal to 7x plus 50 minus 50. All right, let's solve this. I'm going to subtract x from both sides, and simultaneously I'm going to add 50. I'll just make our work a little faster. On this side, our x's cancel. 50 plus 4 is 54. 7x's minus 1x gives us 6x's, and our 50's cancel. I find x by dividing by 6. Sweet, I found x. Well, let's find our angles. I only need to plug x into one of the unknowns because they're the same. And this one looks way easier. All right. 9 plus 4 is 13. I'm going to erase that. Didn't need to write that down. So this is 13 degrees, and this is 13 degrees. Well, what should the other two be? Well, this 13 degrees is a linear pair with whatever this angle is going to be. Just like this one is a linear pair with this unknown or this unknown. All right, a linear pair means we form a line, which means it's 180 degrees. We subtract 13 from 180, and we're going to get 167. So both this angle, whatever its name is, and this angle are both 167 degrees. Okay, I hope this was helpful. And if you have any questions, please be sure to ask myself, your supervisory teachers, or your math teachers. Have a good rest of whatever time of day you're watching this.